Okay, I wanted to speak a little bit about the basics of analog synthesis and especially of modular synths. So when people ask me, I've never heard about analog synthesizers, can you explain me what the hell it is? I say, okay, give me, I don't know, 15 or 20 minutes and I think I will be able to tell you the basics of modular synthesizers in 15 or 20 minutes. The idea is to compare the synthesizer with something everybody knows, that's the human voice. Everybody knows about his voice. You may have heard about oscillators or filters or amplifiers, which are used in synthesizers. And I will tell you that exactly the same things already exist in the human voice, so it's very easy to understand a synthesizer. The basic sound in the human voice is generated by the Stimmbänder, that's voice cords, I think. Voice cords, I think, yeah. How? Vocal cords, right. And the vocal cords is one of the basic sounds in the human voice. And another important thing is something noisy, that is the airflow through the teeth, something like that. So these are the two basic sounds in the human voice, and you find exactly the same again in the synthesizer. The VCO is nothing but the chords for the human voice, and the noise generator, modular synth, is nothing but the what you do when you press air through the teeth and through the mouth. And the next, what happens in the human voice is that the overtones or the filtering changes, and this is done with a mouth shape. So you can generate a basic sound with the chords, and then you can change it with the shape of your mouth, like that's nothing but filtering. So we already have now oscillator, noise, filtering, and the VCA is nothing but the loudness. The loudness is also controlled in the human voice. It depends how strong the air flows through the chords or through the teeth, so you can make more loud or less loud. There's nothing but an amplifier. So we already have the main functions, which you will find again in the synthesizer. That's oscillator, noise, filter, and amplifier. And now I will try to find the right modules to show you the same things you know about your voice in the modular synthesizer. If anybody has questions, don't hesitate to interrupt me. I will be happy to tell you if you need more details. Okay, let me see. For example, here we have two oscillators. They are called in the modular system voltage controlled oscillators. In the voice, the pitch and the loudness and the filter is called by a brain. Of course, in the modular system, you don't have a brain. You need another parameter to control everything, and this is voltage. Voltage is used in the modular synthesizer, for example, to control the pitch of the oscillator, or the frequency of a filter, or the loudness of an amplifier. So that's why they are all called voltage controlled. Voltage controlled oscillator, voltage controlled filter, voltage controlled amplifier, because the voltage is does the job of the brain in case of the human voice, where the brain controls the mouth shape and the chords and the pressure of the air. Okay, now let's see what we can do with the modules compared to the human voice. The difference between the chords of the human voice and the oscillator is that the oscillator is available to generate different waveforms. The basic waveforms that are normally used are sawtooth, triangle, rectangle, and sine wave. Okay, now let's listen a little bit to the things I told you. Here we have an oscillator, and I connect it to the sawtooth output. Let me see, this should be that one. No, this one. Okay, already there's a sequence already running. Okay. I will add something because I have a small oscilloscope here, so you can see also what you hear and what I'm talking about. And I will make a patch so that you can see and listen simultaneously. For this I need a so-called multiple. A multiple is nothing but a module that connects two or more signals. It's just a short circuit between signals. So I take the sawtooth and I go to a multiple, and with that multiple I go to the mixer. Okay. So now it's just the same patch as before, but it is running via the multiple, and here I have my patch cable for the scope. And I connect it to another socket of the multiple. So, okay, and focus. Position. So now we have here. Do you see it? Okay, here. Yeah. But the aliasing you see here, that's caused by the video camera. Here I have a steady signal. I don't know. Anyway, because the frequency of the video somehow is makes it aliasing. Okay, this is the sawtooth. Sawtooth is the waveform which has most of the overtones. When the synthesizers started, I don't know, 40, 50 years ago, so the idea was to copy the sound of existing instruments like violins or trumpets or whatever, and the sawtooth wave was at this time mainly used for trumpets or metal wind instruments. Today, the synthesizer is totally different. Nobody tries to copy an existing sound, but back to history, the idea was to have a machine that is able to create the same sound as a violin or trumpet or flute or whatever. Today it's different. And for metal wind instruments, the sawtooth was used. For woodwind instruments, the rectangle was used. It sounds different. And it's also possible with a rectangle to change the pulse width. You can see it here. The pulse width is the relation between the high and low level of the signal, and it changes the sound and changes the overtones. And another very often used signal is triangle. It has much less overtones, sounds not that bright, but is also useful for some sounds. Okay, that's the same function which is used in the human voice with the chords. Now it's possible, of course, to change the pitch. The pitch is changed, for example, by a manual control like that. Or you can use any external voltage to change the pitch. For this, each VCO has a control voltage input, which can be used to change the pitch. But I will tell you more about this later. Now we will go to the next function I wanted to explain to you. That's a filter. The filter is what, let me see, is done in the human voice by the shape of the mouth. What I do is I connect, let's take the sawtooth of the VCO to the audio input of the filter. The black unit here, you can see, is a filter. It's a special filter. It's called WASP filter, but at this time it doesn't matter which type of filter it is. It's just the copy of a synthesizer that was called WASP, which was available, I don't know, 30 years ago from an English company. Okay, we take the output of the VCO, go to the audio input of the filter, and we go to the output of the filter. The filter has also manual control for the frequency, which I operate now. That's exactly the same which you do with your mouse if you make wow, wow, wow. So this is the second element in the standard patch for a synthesizer. And also there's also a function that's called resonance. You can do this also. You can change your mouse so that to the original sound of the chords, a little bit more of resonance is added. You can make something like ow, wow, wow, but you can make ow, wow, wow. You can add more resonance. That means that several overtones are more emphasized, and that's called resonance. Filter has also resonance control. This is the frequency, and this is the resonance. This is more resonance. This is less resonance. You can increase this resonance very high, that it's close to what is called self-resonance. Okay, well, this was the filter, and you also need something to control the loudness. That's what you do in the human voice with the air breathe with your lung. And for this we need a VCA, voltage control amplifier. Let me see. Okay. Here we have 4 voltage controlled amplifiers. As far as I can see, I have not a single voltage controlled amplifier here. Anyway, I will use this. What I do now, I take the output of the filter and connect it to the audio input of one of these 4 VCAs. VCA is the abbreviation for voltage controlled amplifier. Okay. And I take the output of the voltage controlled amplifier. I just use the first of the 4 voltage controlled amplifiers. The audio output of the filter goes to the audio input of the voltage controlled amplifier, and this is the output of the voltage controlled amplifier. So now we have also the function that we can control the loudness. Yeah, okay. So at this time we have 4 parameters we can control. The first one is the pitch of the oscillator. The second is the frequency of the filter. The third is the resonance of the filter. And the fourth is the loudness. Okay, and that is already the basic patch of each synthesizer. Okay, this does not yet sound like what you expect from a synthesizer. For this you need something to control these parameters somehow. In the human voice, the brain is used to control these parameters. So if you are singing or if you are speaking, your brain does nothing but control these parameters: the pitch, the loudness, the filter, and the resonance. That's all that happens in the human voice. Now we need something to make it more musical, because this is only a steady tone where you cannot do very much. For this we have several possibilities. Most of you will be familiar with keyboards. You can use a keyboard like that one. I know I can. Yeah.
You can just drop it over there.
Okay. Okay. You can use a keyboard like that one to generate parameters which are used to control the elements I already showed you. For example, this keyboard has a pitch output. Let me see. It has a pitch CV output. This output generates a voltage that depends upon the key you press on the keyboard. What I do now is I simply connect the CV output of the keyboard to the CV input of the oscillator. So, what happens? Keyboard generates a voltage which feeds the oscillator. Okay, so it's already a little bit musical. The next one, virtually each instrument or even if you speak, you don't have a permanent tone. There are some exceptions. For example, organs. If you play the key on an organ, you have a constant tone. But normally, a guitar or piano has a so-called envelope. That means if you pluck the string, the loudness increases very soon, very immediately, and then slowly it becomes more and more smaller. So in the human voice, this is done by the brain. I already told you. But in the synthesizer, we need something that is able to generate such an envelope, as it is called. Envelope because it has a so-called attack phase. That means how fast, how long it takes until the maximum of the loudness is reached. And then it has a so-called decay. That means how fast it goes down the loudness. For example, if you pluck on a guitar a high note, the loudness becomes very soon smaller. If you pluck a lower note, it's longer. Same is for the piano. If you play on the piano a low key, it is like dong. So you have a long decay. And if you play a high key, it's ding, because it's very short. Okay. For this, we have a so-called envelope generator available. The envelope generator also generates a voltage, but in this case, the voltage does not depend upon the position of the key, but it uses the information when a key is pressed. And this information is called gate. Gate is nothing but a voltage that turns high when a key is pressed and turns back low when the key is released. And this information is used to control the so-called envelope generator. And in the envelope generator we have mainly the parameters attack and decay. I will tell you later that there are more parameters, but for the beginning it's sufficient that we have attack decay. Attack is how fast the envelope goes up as soon as the gate signal comes, and the sustain or decay is how long it takes that it goes down when the gate is released. Okay, I will show you this. This keyboard has also a gate output, and I connect the gate output to the gate input of an envelope generator, which we have here. Okay, this is the gate input of the envelope generator. The envelope generator has available an LED, you can see on top here, which shows the voltage. Let's see. Okay, if I press down the key, you see that the LED turns on and then goes slowly down. And now I use this voltage. Let me see where it is. I use this voltage, for example, to control the filter frequency. I connect the output of the envelope generator to the CV input of the filter. Okay, and what we now hear is like that. I take the frequency down. So, the position of the key which I press defines the pitch of the VCO, and whenever a key is pressed, the envelope generator goes up and goes down, and this envelope voltage is used to control the filter, and it can be used also to control the loudness. If you listen carefully, you always hear a little bit, because the filter does not close fully. The filter always lets a little bit pass through. So we use the output also to control the loudness of the VCA, the voltage control amplifier. So let me see, I hope this is the right one. Okay, I take the same voltage. It has the envelope generator has two outputs with the same voltage, as far as I know. I hope I'm right. And so now I use. Okay, what I have now is that the envelope generator output does not go only to the CV input of the filter, but also to the input of the voltage controlled amplifier. So when I play a key, it turns on, and if I release the key, it turns off because the VCA goes also down. So that's the basic patch of a synthesizer. Of course, you can play around with all the parameters. You can change the pitch. Or the envelope height. That means how much of the envelope is used to control the filter. If I turn it to 0, now the filter is not controlled by the envelope, just the loudness. The filter has always the same frequency, it does not change. Only the loudness goes up and down controlled by the voltage of the envelope generator. Now I can add a little bit of the envelope to the filter frequency. What I did now is at first no envelope to the filter, and then a little bit more envelope to the filter. Okay. Then I'm not a great keyboard player. That's why I designed many years ago something that's called sequencer, an analog sequencer. An analog sequencer is kind of keyboard replacement where the control voltages, which are normally controlled by the position of the key, are now generated with control knobs. And when the control knob is fully counterclockwise, you have a low voltage or low frequency. When the knob is fully clockwise, you have a high voltage, a high frequency. And what I do now is I remove the CV input of the VCO, which came from the keyboard, and connect it to the output of this sequencer. I will explain what the sequencer is doing. Okay? This is step 1. Step 2 is I also remove the gate signal from the keyboard, which tells the envelope generator when it has to start, and I connect it to the trigger outputs of the sequencer. Okay, this is the first trigger output of the sequencer. I use this one. Just a moment. Okay, then let's start. Okay, here you see the sequencer that it's running. These are the knobs. I have 8 knobs, which are used to find 8 different voltages, and the LED shows the position of the sequencer. And the upper row of the switches you can see here is used to generate the gates, which were so far taken from the keyboard. Now, at first I take all the gates off. So no gate is used. So but that you understand what happens now is I open the VCA a little bit. I increase a little bit the pitch. What I do is just a moment, that's wrong, that's wrong. Something's wrong. Okay. So I take the output of the of the sequencer which generates the voltages which are controlled by the knobs. I connect it to the input which was before that used to connect to establish the connection to the keyboard. Now it changes the pitch in a way that is controlled by these 8 knobs. It's the same if I would play that. So for the oscillator, there is no difference where the control voltage is coming. In the first patches was coming from the keyboard. Now it's coming from a machine which somehow simulates a keyboard, which generates voltages one after the other. The gate is not used at the moment, but now I use it. I connect. It is already connected. I turn the VCO down, and now on several steps, I turn the gate on. At first, let's make it easy, I turn them all on. So, whenever the sequencer advances to the next step, a gate signal is generated. That's exactly the same as if you would play on the keyboard. And now you can play around with all the parameters like before with the keyboard. You can go down with the filter frequency and add a little bit of the envelope to the filter frequency. I'm just playing around with the filter frequency, the manual filter frequency, and how much of the envelope goes to the filter. And then now you can make it a little bit more musical if you turn some of the steps off. Okay, that's my first piece of music. Yeah. Well.